I am Dr. Narsing, Professor of Physics, Dean Research and Development, Marri Reddy Institute of Technology and Management. So today we will study about the nanotechnology. So how this nanotechnology is useful for mankind as well as the technology. So initially it will be all in bulk materials. That means in terms of micrometer size. So where this classical mechanics is prevails, as well as Newton laws will be applicable. So whereas this particle size of that material will be reduced to nano size, then totally the theorems also it will change to quantum mechanics theories. So classical mechanics is not applicable. Some of the properties of nanomaterials. So this quantum mechanics came into picture. So today we will study about the what is a nanotechnology and nanoscale, what is meant by nanoscale, and quantum confinement, surface to element. These are the topics I will cover in this nanotechnology. So usually nanotechnology is nothing but it's the creation of functional materials. So that is functional materials is nothing but it will be applicable in a different type of applications like devices, and it will be controlled in the terms of nanoscale length. That means nanometer length scale. These properties of the materials will be it's like very exciting properties will come out. So that means the properties will change compared to bulk materials. It may be physical, chemical, biological, optical, magnetic, whatever the property you took, that will be changed with in a nano size. So wherever the bulk material will show in one type of material, then if it is a nano size, then that will be properties will change drastically. So that is depends on the length scale. That is a nanoscale. So that is what is nanotechnology means that the creation of functional materials, devices, and system through control of matter on the nanometer length scale by exploiting novel phenomenon and properties. Whatever the novel phenomenon we have, that is conductivity, resistivity, as well as optical properties, absorption, transmission, magnetic, ferromagnetic, paramagnetic, all these properties will change according to nano size. That is nanotechnology, it will tell us. So what is mean by nanoscale? Nanoscale is nothing but we all know that there is a nanoscale means it will be 10 to the power of minus 9 meters. 10 to the power of minus 9 meters, we will say it will be nano. There is a scale will be there in means symbol, this measurement symbols like milli, Kelvin, kilo, mega, giga, like that. There is a nano, tera, like that. There is a different type of scales will be there. So here in the nano means it will be 10 to the power of minus 9 meters actually. So it is a 1000 millionth of meter. That means more than 1000 million. That means I think it will be 1000 millions into 10 to the power of minus 6. So that means totally 10 to the power of minus 9 actually. That is 1 millionth. That means 10 to the power of 6 by 1000. 10 to the power of 6 by 1000 is a 1 millionth of a meter. That means it looks to be 10 to the power of minus 9 meters. So that's a parameter, that is a constant value of this nanometer, that is the scale. So is the scale will be nanometer. Okay. So how it will be looks to be the nanoscale, because of this scale, physical properties as well as chemical and mechanical properties also it will change different from the usual bulk materials. You can see this material is a bulky ball. They will call it as a buckyball, or we can say it will be fullerenes. So it's a very important material for means like what I'm saying is in mechanical strength and as well as the chemical reactions. This carbon is a most important one. So you can see in 1 nanometer there is a 60 carbons are aligned. The 60 carbons linked together in a one unit, that is called it as a 1 nanometer. So that means that small amount of uh, scale will be there in a nanometer. Okay. So that is a 60 carbons. That means carbon one, it will be reduced one. Okay. So this buckyball they will call, it's like a ball, but there is a attachment of all carbons. Okay. So then actually the how big is nano? So usually if you are measuring like earth by football, there is a ratio will come, na? The ratio of earth by football. So whatever the value it will come, it will be similar like football by fullerens, that is buckyball. Okay. So that means the value, that means the ratio is equal when earth by football, that is very huge value will come now. That's earth means very big area, football means very small. Similarly, for football versus fullerens, you will get the similar value of that ratio. That is how that scale will be, depends on that. So it will be millionth of millimeter or billionth of meter. That is just a scale how it will be represents that nanometer. Okay. So this ratio, it will be earth by football. You just please remember that value will be very huge value. Similarly, the football by fullerens, that is also similar ratio. So it will be that nanoscale will be like that they are explaining. Similarly, so how big is nano and how it will be, we can measuring or not. So you can see if it is a beard man, it grows 5 nanometers every second. 5 nanometers every second. This beard will increasing every second. That is 5 nanometers. Similarly, our nails. So the nails also, women fingernails also, it will grow 1 nanometer for every second. 1 nanometer for every second, this one will be increasing every, means that's a physical means in our body also, it depends on this size of the nanometer, how it will be. Every second it will be 1 nanometer, it will grow of the our nails. And you can see the comparison. If we have a air, that is air will be in terms of micrometer. This is the air thickness, you can see here, that is in terms of micrometer. But you can see there is a wire, white one in the graph, there is a white one like a line. So this is the silver nano wire, this nano wire. You can compare this total means air. In that air they combined with silver nano wire. So you can see there is a very small value. That means what I want to tell is why the nano is how it looks to. Okay. So like that, the air will be like this micrometer size. Then the nano wire of silver, you can see there is a small like this one is a our body to air, how it looks, this one air to nano wire, that like that the difference will be the nano as well as that air. That is how big is nano, we can see that. And what is the nanoscience? Nanoscience is nothing but to study and manipulation of materials at the nanoscale. That means that is called it as a nanoscience. That means study, we have to study what are the properties, we want to look that one, and the manipulation of material. That is if you have a big particle, so you have to make nano size, then how to manipulation that nano, that is also one of the science. Nanoscience, it looks to be properties as well as preparation. So why nano is most important in nowadays actually. So at the nanoscale, most of the things, there is will be the strange things will happen in a materials. That means all the properties can change drastically. If you are making one type of absorption is there, one if you say there's gold will absorb some light. Similarly, if gold particles, that absorption rate will be different compared to bulk one. So it will be drastic change in nano size most of the properties. So that's a important point in nano. Okay. So that is nano, how it will be changes in size. Okay. As a particle gets smaller, they tend to react differently with their counterpart of bulk one. Okay. So larger particles and smaller particles, totally the reactivity, what in chemistry people, they use catalytic activities. This nano is very useful for there. That is the reactions are different compared to bulk materials. Similarly, the smaller particles can have different optical properties. What I told, that is a different absorption rates as well as the transmission rates. Whatever you take that property, it will change according to these smaller particles. So their color change because of different sizes. So another important thing is the color change is nothing but the absorption rate will be different. Absorption is one of the property to make the materials will be different colors. Okay, so then the particle reflect and absorb light differently, that absorption as well as reflection. So you can see that my body, so my body is, looks to be one place in one color, another place is another color. This depends on the absorption as well as reflection rates of these light falling on my body. Okay, so then there is a magnetism also. Magnetic properties will change when the particle is smaller size in terms of nanometer. Okay, it has different magnetic properties. We all know that there is a three basic magnetic materials, that is a ferromagnetic, paramagnetic, and diamagnetic. So these properties will change when the material is in a nano size. So that's the beauty of this nanoparticle or nanotechnology development. So knowingly or unknowingly, so we know the olden paintings. So olden painting, that is hundreds of years ago. So there is a one painting. This is a famous painting actually. So whenever the painting classes are there, these pictures they will show. So here they don't have that time they don't have different colors of paints. So this total may be only one color only, one material only, but the different colors will depends on the particle size. Okay, for clarity, you can see here the red one, these strains, the red ones will be, it will be color of nanoparticle of gold, that is approximately around 20 nanometers. Actually, gold will be light yellow color, but if the particle size is around 20 nanometers, the color will change to red color. So there they use the red color gold nanoparticles of the size of 20 nanometers, then it becomes red color. So that appearance will be depends on the particle size. So similarly, the orange glass, and this orange also, it will give the color of 80 nanometers. 80 nanometer gold particles will give the orange color. So this blue also, it depends on the particle size only. So that means this total painting is related to gold painting only, but they use different sizes of the particles. That's gold only, but different sizes of the particles, they show different type of colors. Okay, so that's important in that is very earlier days only, before this nanotechnology came into picture. Then itself they make all these things without knowing also sometimes, because that time they don't have that what I mean is experimental setups to measure the particle sizes. Okay, but now they took that pictures, and they see that how the gold is at which color, which particle size it will be, the different colors, how it will be. I will show you that colors also. And another thing is the dissolving. So if we all know that the sugar cubes will be there nowadays. They are using sugar cubes also, but there is a granuled sugar we are using from childhood onwards. It's long back. But this sugar, which sugar it will be dissolved fast? So the sugar of granuled sugar will be dissolved fast. That means the bulk one, that means sugar cubes, it will be dissolved slowly. Similarly, if you are nanoparticles, then it will be dissolved very fast. So that's what the property, why the property is changing with the size of the material will reduce. So this bulk size, it will be in terms of few millimeters or maybe centimeters. So if this granuled one, it may be few mm, so maybe 2 mm or 3 mm granules will be there. if these granules will dissolve fast compared to these 10 or 1 centimeter cube of sugar. Okay. So that means the dissolving nature, that means the reaction rate also changes with particle size reduces to the nano size. It will be drastic change in the dissolving power also. So usually nanomaterial means, so at it will be depends on the at one direction. That means at one direction, if it is a nano size, then they call it as a nanomaterials. Like this rod is there, or some wire is there, but this length, this one, it will be long length, but the diameter will be very small. That is in terms of nano. So that means this is, we call it as a nanomaterial. That nanomaterial we call it as a, but only at one direction. Due to this one direction, we call it as a one dimensional nanoparticle. If the any dimension is reduced to nano, that material we call it as a one dimensional nanoparticles or nanomaterials. So usually it will be like a thin film or surface coatings. The surface coating, it will be, the thickness of the coating will be nano size, but it spreads width and length will be more. So that's why we call it as a one dimensional nanomaterials, that is thin film or surface coatings. Similarly, in two dimensional, so this wire width and thickness, it will be nano size, but length will be more. So that's why this material we call it as a two dimensional nanomaterials. Two dimensional means, two means that length, width or breadth, that is three dimensions are there. Na? That three dimensions, at least two dimensions, it becomes nano size, then that material we call it as a two-dimensional nanomaterials. The examples are like nanowires and nanotubes. So these are the materials. If you make nanowire, it will be two-dimensional nanomaterial. If you make thin film or surface coating, then that material we call it as a one-dimensional nanomaterial. So similarly, if it is like a point in all three dimensions, that means x, y, z, all three dimensions, it will be in a nano size, then that is called it as a three-dimensional nanomaterial. It is called it as a quantum dots. So these quantum dots are nothing but there is a semiconductor material, the small particles of semiconductor. It acts as a individual particle. It's in terms of nanometer, 2 nanometer or 3 nanometer. That's a surrounded, means like a circular one or a rectangular one, whatever it will be. It should be within less than 1 or 2 nanometers. That we call it as a quantum dots. That is, usually these quantum dots are useful for semiconducting materials like a semiconductor industry. So the quantum dots will be very useful one. So these are the three different type of materials. One dimensional means any one dimension, any one direction, it will be nano size. It x may be or y or z. So one dimension, one axis, it should be nano size. Then we call it as a one dimensional nanomaterials. Similarly, if the two dimensional x and y, it will be nano size, and third one may be very long like micrometer also, we call it as those materials, we call it as a two-dimensional nanomaterials. Similarly, another third one is three-dimensional. In all three directions, x, y, z. So all three directions, it will be in nano size. So that material, we call it as a three-dimensional nanomaterial. It is like quantum dots are best example for that three-dimensional materials, nanomaterials. This is the nanomaterial. And why these nanomaterials are important, and why these nanomaterials are different compared to bulk materials. That's actually two phenomena, that two phenomenon will be there. Those phenomena are more, due to those two phenomena, these nanomaterials are more effective compared to bulk material. Okay. So that means nanomaterials are very much different from those at a larger scale. So nanoscale and larger scale, if you take larger scale, it will feel the property, that means some physical property, that is optical or magnetic or like mechanical, whatever the property, it is bulk material, it will show, but it is not necessary to show in a nano size. So that's a different properties will differ with the size. So there is a two principal factors. It will affect the properties of nanomaterials. Okay. So where it will be differ significantly to the bulk material. Those are increased relative surface area, relative surface to volume ratio. Surface to volume ratio, it will increase. Similarly, the quantum confinement effect. Another one is quantum confinement effect. So these factors can change or enhance the properties. If the one property is some value is there, this using nanoparticles, that value will be increases. So like that, enhancing properties is due to these two phenomena. One is relative surface to volume ratio. Another one is quantum confinement effect. And the reactivity, strength, electrical current, all these properties will change when the particle is at nano size. So this surface to volume ratio. So this surface to volume ratio, how we can consider? So we can say if there is a one cylinder is there or one circular sphere is there. So its sphere radius will be around r. Sphere radius, we will say it's a r. So its surface area, how it will be calculated? This sphere surface area, there will be 4 pi r square. There is a equation will be there for sphere, that is surface area. Similarly, the volume will be around 4.4 by 3 pi r cube. That is the volume of this sphere. So then if you the ratio of the surface area to volume, so you will get 4 pi r square divided by 4 by 3 pi r cube. So this r square will cancel out, 4 will cancel out, pi will cancel out, then remaining the 3 will go up, then 3 by r will be the ratio of the surface to volume ratio. That is surface to volume ratio is equal to 3 by r in a sphere. So 3 by r means what? The surface to volume ratio increases when the r value decreases. When the r value, that is sphere will be reduced size, you will get the more number of unit of surface to volume ratio. That means whenever this decreasing go on decreasing, you will get the increasing surface to volume ratio. So that surface to volume ratio increases means what? So in a surface, there will be large number of particles will be accumulated. So that is due to this surface to volume ratio increases, then each particle will have its own area. So that because of that total area, the property due to that total area is increases, then the properties will change. Okay. So there is a surface to volume ratio increases when the particle size is decreased. This is a surface to volume ratio. How it will be depends on these nanoparticles. Similarly, if you take like a means a square, okay, if 1 meter square, we know that it will be like a surface area will be 6 sides into meter square. So that means this one total surface area is 6 m square. The volume will be 1 m cube only. The volume will be similar, okay, that because it's a 1 into, that is if a is equal to 1 meter, then this volume will be a cube. So it will be 1 only, but 1 meter cube, that is the value. Surface means 6 m square. Okay. So this cube, its surface area is 6 m square. So if this cube is divided into half, that means if you make this cut with the half, then what will happen? The length will be half m. Then it will be the surface area, it will be divided into 8 pieces instead of 4. Instead of one piece, if you cut with the half, that means 1 meter instead of 1 meter, 0.5 meter, then it be divided into 8 pieces. So that 8 pieces, its surface area becomes 12 m square. Instead of 6 m square, you will get 8 m square. How it will be? Surface area is 6 into half m square. So that is 1 cube. Then you have 8 cubes, that means 8 pieces. So into 8, it will becomes is 12 m square. That means half m square, half m into whole square, that half will be 1 by 4th into 1 by 4 means 8, 6 into 1 by 4 into 8 into m square. That means total 12 m square. So that means the surface area, if it is a big size, converted into smaller size, half, then the surface area becomes twice, 6 m square to 12 m square. The volume will be same. The volume will be same value, but the surface area will be increases when the size is reduced. Similarly, this volume, this cube divided into 27 pieces, then surface area becomes 18 m square. That means the surface area, once again, it will be increases when the size of the cube will be reduced. So that way, so the surface to volume ratio, volume is same. So surface to volume ratio, so this surface is increases when the particle size or cube size is reduced. So then automatically the surface to volume ratio will increase. So that's surface to volume ratio, how it will be reduced with the reducing particle size. So as the particle size decreases, a great proportion atoms are found at the surface compared to inside. So if you the surface to volume ratio increases, then the surface in above the surface, the particles will be more compared to inside. So that's another important point where the properties, total properties will drastically changes using this type of phenomena. So with the same, this same much greater surface area for given volume compared to larger particles. So it make material more chemically reactive. So how it will be react with the chemicals? Okay, that means it will be bonding of the atoms. If the particle size will be reduced to nano, then how the particles will be aligned. Okay, that's also important point. So you can see that how the gold. So gold color will be light yellow color. We all know that. So it will be almost reached to 1 lakh for 10 grams. So now it will be reduced little bit, but it will be 1 lakh at means 1 lakh for 10 grams. Okay. So if you are making this gold into nano size, then you can see the size changes to lower size, then the gold color will be different. You can see there is a blue color, light blue color. So if you are go on decreasing the particle size, it will becomes red color also. So that means the particle size, it will depends the color of the bulk material. Okay. So if the bulk is light yellow color, but if the size reduced, it becomes a red color also. The same yellow color, it becomes red color at lower particle size. You can see the particle size, big particles means the big one, you see it will be yellow color only. So that yellow color particle is reduced to some half of that one, then color will change to this like purple color. Then it reduced to another half color, half of the diameter, then it becomes red color. Similarly, there's a light red or pink. Like this, different colors will be produced while the particle size reducing. Okay. So that means at different sizes, it will the reflecting rays as well as the absorption rates will be different using this same material. It will be gold only, but the particle size reduced, so you will get the different type of colors. That means the color different y means it depends on the absorption and reflectance rate. So there's a bulk material, it will absorb some type of radiation and it reflect that radiation. If the particle size is reduced, the absorption rate as well as reflection rate will be different. So due to that difference, you will get the different colors. That is gold particle, how it will be depends on this particle size. So now if the particles, this gold particle is there, so gold means it will be conductive. So like if you plot any curve using this resistance versus temperature, this gold is conductive. So that means it will go like this. At reducing temperature, it will go reducing. So the resistance will go reducing. But what happened if the particle size is reduced? So the particle size reduced, the resistance value will depend. Okay. So that resistance value, maybe it will increase the resistance value, because the surface volume ratio will increases. So that surface volume ratio increases, the grain boundary will come out. The more grain boundary, that means if the center point is the less atoms, outside it will be more atoms. These more atoms, it will connect to another one. So that means if the flow of the electrons, it will be difficult to cross this boundary. So due to these grain boundaries, the resistance of this material, it will be increases. Resistance will increase. So it becomes, if the size is very nano, then you will make this metal may be related to semiconductor also, if the particle is very low value, smaller particles. So that way also it is a possible. That means the metal becomes semiconductor when the size of the particle will be reduced to nano size. Similarly, this is a transport property. But it's a metal one. If you take another type of material, some material like insulating material, you can say. Insulating what? It will be some type of oxides. So that oxides, due to this grain boundary, so there the actually grain will be insulating area. But grain boundary, due to this grain boundary, it will be easy to flow electrons. So there is a two different mechanisms. So that still there is a controversy is there, not controversy. There is a different type of phenomenon they can explain like that. So the gold, it will be conducting. So then it will be easy to transport that one. But insulator, if it insulator to insulator, this grain boundary will also act more. So due to this grain boundary, it instead of insulating, so it may be semiconductor also possible. That means it may be reducing resistance. Some materials it will be increasing the resistance. So this type of behavior is applicable. That means the properties will change drastically when the particle size is nano. This transport one. So similarly, the magnetic, how it will be. So the magnetic, because magnetic, if you take any ferromagnetic material, ferromagnetic means what? If the magnetization versus temperature, if you plot that graph, magnetization versus temperature, so then at a higher temperature it will be paramagnetic only, but at at particular temperature the magnetization will increase. This part they call it as a Curie temperature, the TC. Ferromagnetic, when at that time all the alignment of spins will be in magnetic field direction, so you will get the more magnetization at this point. So it will be continuous increasing at lower point, lower temperature side. Okay, so this one we call it as a Curie temperature, but this is a like a Fe3O. Let us take it as a Fe3O4. This is a bulk material, iron oxide. Iron oxide, we all know that it's a old ferromagnetic material. Old magnets they will make using this material earlier. So this is a ferromagnetic at particular temperature. Okay, at above room temperature only it will be ferromagnetic. So this ferromagnet, if you are making this Fe3O4 in a nano size, what will happen? The same property will come or not? But usually that same property it won't be appears. Here it will be ferromagnetic property. If you are making a iron oxide, if it is a 10 nanometer or 15 nanometer, so this property becomes, what will happen? It will be super paramagnetic. What I mean is, there will be another terminology. There is a magnetism. We know the only 5 general terminology, that is diamagnetic, paramagnetic, ferromagnetic, ferrimagnetic and antiferromagnetic. But there is a in between, there's a lot of magnetic phenomenon will be there. So similarly, if it is iron oxide is a ferromagnetic usually. So this ferromagnetic iron oxide, if you make nanoparticle, so this ferromagnetism will be disappear. Ferromagnetism, this value will be almost around 90 EMU something it will come. EMU for gram. 90. That means almost pure iron oxide, you will get around 90 EMU per gram. That is the units. Okay, the value will be around 90. So that is ferromagnetic one. If the particle size is reduced to nano size, this 90 becomes, maybe sometimes it will be 0.9 or zero point 0.9 EMU per gram. So that means the drastic change will come, but the behavior also it will change. Usually it will be at lower temperature, it will increase continuously, then at lower temperature, that means it may be around 50 Kelvin or something. This one is more than 300, but here there is a 50 Kelvin, you will get the maximum value. That is, there will be magnetization if you measure with the zero field cooled, like that. There is a field cooled and zero field cooled, there is a terminology will be different. So the different terminology. This one, the behavior, they call it as a super paramagnetism. So that means at these spins will be inside, it will be frozen. So then after heating of that material, so suddenly it will be means all will be aligned in a magnetic field direction. So if you are making that higher magnetic fields, then it will go like this. But still the value is drastically decreased from bulk to nano size. That's a important phenomenon. This is nano size, the ferromagnetic becomes, the value becomes less. So because of this less value and this type of super paramagnetic behavior, so these nanoparticles of iron oxide is very useful for health purpose. Health means health industry. Like EM means what we are saying, that is there is a spectrum will be there, EMR spectrum, electron magnetic resonance. So in this one, these spectra, so they are magnetic particles that they use nano size particles, okay, not bulk one. So nano size particles they use, so it will be very useful for medical applications, these nano size particles. That is one of the application of the iron oxide. This is a magnetic property. Similarly, there is a optical property we can see. If the optical property, how it will changes. So usually optical property means like absorption. If there is a silver is there, gold. So if you gold, you can see there will be maximum will come at a particular wavelength. This is the wavelength versus absorption. Wavelength versus absorption. If you see there is a maximum at particular wavelength. If the particle size, this one may be around a micrometer size, we can say. That means bulk one. So if the size is reduced to nano, then there will be reducing this value. The maximum value will be reduced. Because of this absorption maxima, so your color will changes. This here it is VIBGR wavelength. So if the color will change because of this absorption rate. This absorption maxima will reduced when the particle size is reduced to nano. So that's because of these, the particles like color will be changes. That is optical property. Okay. Another one is mechanical property. You heard about recently there is a like what we call it as a, what this buckyball I told na, that's there is a carbon vapors, like that, carbon vapors. So there is a Nobel Prize also came on that particle, that one. So it's a nano, like a flakes, nano films, like this carbon. So this carbon nanoflakes, or it will be like a buckyball type material, or we can say carbon nanotubes. These all are, is the strength of these carbon nanotubes is more than iron. Our strongest material is this one, the carbon. Okay. So that is also one of the important mechanical property will change while the particle size reduced to nano. So normally if it is a carbon, so we can crush that carbon, normally if it is a bulk one. But if it is a nano size, we cannot crush that one. It will be strongest material up to now. It's the strongest material prepared compared to iron. Steel also less strength compared to this carbon flakes. That is a important observation, important study, research study. So those people are got a Nobel Prize on that material. So that means the particle size is makes significant role on all the physical properties of these what we are studying in uh, bulk materials. Whatever we are using in a bulk one, if you make that material into nano, so you will get the large values of increment or decrement, depends on the material. If sometimes it will be the value will be increased, sometimes value will be reduced. The reducing value also very important sometimes, because like iron oxide magnetism, so that that much magnetism is not good for health, but the smaller magnetism it will be okay for health. So that's why the nanoparticles they use mostly in medical applications. So most of the our like what I'm saying is the beauticians they use the all different type of emulsions. Those emulsions also related to nano size only.